So this is x squared. So we can, if you are given to differentiate EU, what do? If they say find the derivative of, find d du of this, you differentiate u and then multiply by the whole function like this. So if they tell us to integrate this guy, then it means that its the integral with respect to u is going to be EU plus C, like that. So here, if we let u to be x squared, then du is going to be 2x dx. If you divide by 2, you divide by 2, then we'll have x dx is equal to du over 2. Then we go and substitute. So where there is x dx, we'll put du over 2, and where there is x, we'll put u there where there is x squared. So this can be written well as half EU du, like that. Isn't it? I'm thinking this. Yeah, and then the integral of this is what? Let's see. What's the integral of EX dx? It is EX plus C. So the integral here is half EU plus C. But what is U? U is x squared plus C. This is the solution. If we doubt, you differentiate it. Half E x squared plus C. We'll get half 2x E x squared plus 0. The halves will go, so we'll have x E x squared, which is our question. By parts. Look, if you try by parts, you'll say, let U be E x squared, because you can't allow U to be, you can't allow the one to be integrated to be E x squared because you can't integrate it. And then you say, let dV be x. Then you have V x squared over 2. And you have du 2x E x squared. Then the combination will be x squared over 2 E x squared minus the integral is going to be x3 E x squared dx. It has become more complicated than the original question. So this, super cool, right? That's why I said question 1 looks like it's just substitution throughout. So you got question 2? Or we ran through the whole question 1? You're free to suggest. Anyone to say something?
Maybe we can go through.
Okay. Let's go to question B then. B, the integral of x squared multiplied by 2 x power 3 plus 1 dx. Yeah, this plus 1 is in the power. So let's see. If I'm told to differentiate AU, how do we differentiate AU? You first let the variable y to be AU, and then apply ln so that you drop U, and this is A like this. Then when you differentiate using implicity, you have like 1 over y dy du is equal to ln A. Then you get dy du is equal to y ln A, which becomes ln A, and then y is A power u. This is how you differentiate the exponential with a constant, and that is not E as a base. So you know what we are doing here? We want to assimilate this whole thing here for our question. So we say the question given, if we let u to be x to the power 3 plus 1, then du is going to be 2x squared dx. Like that. Then to differentiate, because here the standard derivative then is going to be oh yeah, 3x squared. Yeah, you're right. 3x squared, like that, dx. Then if we write now, well, this is like going to be the integral of 2 power u. If we divide by 3 here, by 3, then we get du over 3 is equal to x squared dx. This is going to be 2 to the power u du and 1 over 3 outside, like that. Then how do we integrate this exponential to the power u du? What's the standard integral of a non-exponential thing here? Because I know that if I okay, first, when you're integrating the normal exponential, we fix it. We don't even need its base. Yeah, nothing. So So this integral will need this part here. So the integral of this is going to be 1/3 and then 2 to the power u divided by the ln of 2 plus the constant c. Like this. So that because we know what u is, then we'll have 2 to the power u is x3 plus 1/3 ln 2 plus c. Yeah. Now, I'm not so sure. So let's check if that is true. So we'll differentiate with respect to x. We'll differentiate 2x3 plus 1/3 ln 2. C is okay because we know it to be 0. The derivative of the numerator here is here. So we'll get ln A, but u place 0. So there's u prime down here. There's u prime. The standard one should have like ln A, u prime, a to the power u. This is the standard derivative. So we differentiate the power, we'll get 3x squared, and then ln 2, and then the whole function. So 2 to the power x3 plus 1. But what we have here has the denominator this, so that this 3 takes away this. This guy goes with this. So end up having x squared 2x3 plus 1. Yeah. So these, like, normally I don't drive them. I just use their derivatives to check what the integral should be. I hope you can do that again. So you need to know because the simplest thing to do here is to get the derivatives of the exponential. Then if you know the setup of the derivative, then you can know what is missing when they give you an integral. You know that, oh, so this part is not there, so I'll need these pieces. So I need these pieces for it to come out. So like, we start with the general derivative of a to the power u. What is the derivative if I'm given this setup? For us to understand the integral of such functions. So the derivative, you first let this to be y, and then apply ln so that you can come down from the power. And then you differentiate using implicit. You have 1/y, then dy du, which is equal to u prime here, because you're differentiating with respect to u, it's 1 ln a. So meaning that we get y ln a but then we know what y is it? Y is a to the power u. So you substitute a to the power u multiplied by ln a. Now this, we are taking u to be just like x. But if we take u to be a function and are doing the integration here, then you'd say u prime and then au ln a. So it means that if we are to differentiate this alone here, what you get is something that is sitting like this. But we can't start differentiating this whole thing. If we differentiate this, it will produce this part again. So complicate that thing. So we let the numerator here to be u, which is x3 plus 1 is equal to u. Then we differentiate this u. we'll get 3x squared. Then we want to substitute now here. So as we substitute here, because when we differentiate, we have gotten x squared dx as our du. Though here there was a 3, we divide so that we have x squared, which is here, dx. X squared dx giving us du d3. So we put du over 3. And then 2, we haven't talked about 2, but it's the power, we have said it's u. So we have this setup. Now I want to integrate this. So how do we integrate this? If I've forgotten the general form of this guy, then I'll look at its integral. I'll look at its derivative. The derivative of any constants to the power u is actually ln that constant and then u prime a to the power u. So now because this is the constants that we have here, so we're saying, okay, and we can't see it here. So it means that in our integral, we just need to put this guy in the denominator here. That's why it's not seen on up here. So we'll pick the 2 to the power u, fix it. That 1 over 3 is outside. Then 2 to the power u fixed over ln 2, the constant. So we are now countering this part. We have placed it down. Plus c. This becomes our integral. But what is u? U is this one. Then if you are doubting, because in my case, it's been long since I did this thing, so I'm doubting. So how do I become sure that this is the thing? I would get this whole thing and differentiate it here. And you see that the derivative is actually what we have as the integral. So I know it's correct. It's very, very easy to check always because the differentiation is the easiest thing to do as compared to integration. I hope that's okay.
It's clear.
Okay, so we move on. We'll finish them. Let's go to another one. So we go to C. So C, the integral of x plus 3 e to x dx. So here again, if we want, because here we know no matter what, there will be by parts because of the x. And these x have the same power. So we can't say we can let u to be the power for e. That won't make sense. So we can choose to take this whole thing as our u. So we have x plus 3. And then our dv becomes e to x dx. Then we integrate to get v. We'll get e to x over 2. Then we differentiate here. We'll get dx. Then we put things together. So we're saying the integral of x plus 3 e to x dx is equal to x plus 3 e to x. So I can put over 2 here, minus half e to x dx. And then we integrate that piece there. So the integral now, it would bring 2 down. So we'll just say 1 over 4 here. e2x plus the constant c. And then d, the integral of x squared cos pi x dx. Take pi as a constant and use reduction of this one. If you don't want to use reduction, then use the same by parts where you let u to be x squared and dv to be cos pi x dx. So v is going to be sin pi x over pi. And then du will be 2x dx. So we'll do the integration twice. So this one I know I can talk less because we did the reduction of it. E x ln x power 3 dx. So ln is to the power 3. It seems like we have to use by parts again. U is equal to ln x 3. Let me see if it will make sense. If you differentiate this, you get 3 ln x power 2 1 over x. And then dv is x dx. Then v will be x squared over 2. So the first term we'll have the integral to be x squared over 2 ln x 3 minus 3 over 2 integral, and then we'll just have x ln x squared dx. Since this x down here will take away the power here. Yeah, so it's by parts because it's reducing. Then you just pick this one to integrate. Again, you let u to be ln x squared and dv to be x. So that v again is x squared over 2. And then du is 2 ln x 1 over x. So again, just that part to produce x squared over 2 ln x squared minus the 2's will cancel again, and then the x will cancel one of those x. So we'll have x ln x here dx. Then again, we do the by parts on this one. So I've just remembered that this actually was part of the reduction. As you can see, the way it is reducing. I think we did the reduction of this one. If you check the reduction ones, they can help you. Instead of going through this by parts, you just apply the reduction formula if you can be able to remember. What about f? F, the integral of x e to the power root x dx. So this one, Looks like we can't just go direct into by parts. Yeah, so I think you let u to be root x, so that if you square and square, you get u squared to be equal to x. And then you find dx with respect to u. With respect to u, we'll get 2u du. We'll get 2u. Then you rearrange, you have dx is equal to 2u du. Then you go there up and substitute. So this integral x e to the power root x dx is equal to the integral where there is x, we are putting u squared. And then e where there is root x, we are putting u. And then where there is dx, we are putting 2u du. So the whole thing becomes 2 outside u power 3 eu du. Then we start doing by parts. So we can switch the variables again here. Let u be equal to x, so that we operate with the normal integration that we are used to, ex dx. So that we let u to be equal to x3 and dv to be equal to ex. So v will maintain to be ex, but du will be reducing. The first term to be 3x squared dx. Then we combine, we'll have x3 ex minus 3. Remember, we're not, these two come and get it later. So 3 x squared ex dx. Yeah, right. So you keep going with the with the integral. Yeah, Moses said you finish this one. Then let's comment on G. We have the integral x squared tan inverse of x dx. So whenever you have tan inverse, you can't integrate this one. So you rate it to be u, tan inverse of x. And then your dv becomes x squared dx. Then your v will be x3 over 3. And then du, we differentiate this one now. This is 1 over x squared plus 1. Yeah. Hope I'm correct. I don't know if it's, I've forgotten if it's x squared plus 1 or minus 1. I can check. I don't have it now. I can check. Okay, yeah, it's the 1 over x squared plus 1. Yeah, so then we put things together. So we'll have uv, which is x3 over 3 tan inverse x minus v du integral 1 over 3 here, then integral of x3 over x squared plus 1 at dx. So when you have this setup, you use so we use partial fraction. Now, because that power is up, is bigger than the under. So we use, how do you use partial fractions? If the power is bigger than the other, if the numerator's power is bigger than the one for down, then you first go into long division so that you reduce. And then you come back and apply it. So here we get x, and then you have x3 plus x. Then we'll get, when we subtract, so we'll have negative x here. Then we know that that integral now, x3 over x squared plus 1 dx becomes x minus x over x squared plus 1. So we're integrating this whole thing. Dx. So when you do that, the integral of this x, you know it's x squared over 2. Minus, then this one now you use substitution. So it's going to be like we'll have 2. You rate the denominator, u, to be x squared plus 1. Then you differentiate it. So it becomes 2x dx. So you divide by 2, divide by 2. So x dx is equal to du over 2. So you're substituting here, new integral, you have something like du 1 over 2 out over u. So that we get half, and then x squared plus 1 plus c. But this whole piece, you take it inside here, then multiply by negative 1 over 3 for you to get your solution. So the meeting will be cutting very, very soon. But it's good we have recorded it, so it will be uploaded. Hope you enjoyed question 1. You can come back for question 2.